Determine the following aspects of the function f of x equals numerator x squared minus 6x plus 8 divided by denominator the quantity x plus 2. The first thing we want to find is the domain. To determine the domain, we set our denominator equal to 0 with rational functions. But actually, before I do that, let's see if this can factor. The numerator is x squared minus 6x plus 8, which should factor as x minus 2 times the factor x minus 4, and all that is divided by x plus 2. All right, that'll tell us a few things. So the domain will be 0 if x is equal to negative 2. So my domain can either be written as x such that x is not equal to negative 2 in curly braces, or the interval minus infinity to minus 2, not including infinity, values of infinity plus or minus infinity, or negative 2, union minus 2, not including negative 2 with a parenthesis, to positive infinity with a parenthesis. Now, x-intercepts will be the values that make our numerator equal to 0. So because our factors are x minus 2 and x minus 4, that means our x-intercepts are 2, 0, and 4, 0. Next, we can find our y-intercept by finding or calculating f of 0. So that would be 0 squared minus 6 times 0 plus 8, all divided by 0 plus 2. This would be 8 divided by 2, which simplifies to 4. So our y-intercept is the point 0, 4. Now, going back to our factored form, there are no factors that cancel. Because no factors cancel, we have a vertical asymptote at x equal to negative 2. If something canceled, we would do that and then determine that based off of our denominator. Where our denominator is 0 is where our vertical asymptote is when factors do not cancel. Next, we want to look for a horizontal asymptote. And again, for this, we'll want to look at the degrees of our numerator and denominator. Our numerator has a degree of 2, and our denominator has a degree of 1. Because our numerator has a degree that is larger than our denominator's degree, there is no horizontal asymptote. However, because there's no horizontal asymptote, we need to check for oblique or slant asymptotes. So we'll perform long division with these two polynomials. So we'll do x squared minus 6x plus 8, all divided by x plus 2. And from this we can see that x multiplied by x squared, or x would need to be multiplied by x to become an x squared, so part of our quotient is an x. We'll multiply that newfound x by x plus 2 to be x squared plus 2x. Put that in parentheses and subtract it, being very careful of the signs. X squared minus x squared is 0x squared. Negative 6x minus 2x would be minus 8x. And we'll bring down a plus 8. Because we have a minus 8x, we'll have to say x times negative 8 would be negative 8x. So our quotient is now x minus 8. Multiplying minus 8 times x plus 2, we'd have minus 8x minus 16. Put that in parentheses and subtract it. And we get 24. So our remainder is 24. But that means that our oblique asymptote is y equals x minus 8. Right, for our next example, determine the following aspects of the function f of x equals numerator is 4 and our denominator is the quantity x squared minus 9. Let's first factor this. The denominator factors as x plus 3, x minus 3, since it is a difference of squares. And the values that make our denominator equal to 0 are positive 3 and negative 3. Which means our domain, I'm going to write this in interval notation, is parentheses minus infinity, comma minus 3, close parentheses, union with the interval parentheses minus 3, comma positive 3, close parentheses, union with the interval open parentheses 3, comma, positive infinity, close parentheses. Right, now, because our numerator is never 0, numerator is never 0, we have no x-intercepts. Now for the y-intercept, we can again calculate f of 0, which is 4 divided by the quantity 0 squared minus 9, which would be 4 divided by minus 9. So our y-intercept is the point 0, comma, negative 4/9. All right, because no factors cancel in this, our vertical asymptotes occur at the values we found earlier. X is equal to 3, negative 3, and positive 3. Right. Next, we have horizontal asymptotes. Let's check for that. Well, the degree of the numerator is 0. The degree of the denominator is 2. And since the degree of the denominator is greater, then we have a horizontal asymptote at y equals 0. Based on our rules from earlier, which means that we have no oblique asymptote.